Case study, TechSecure Inc.'s proactive approach to cybersecurity, integrating AI in threat hunting for enhanced protection. Facing growing cyber threats, TechSecure Inc. recognized the urgent need for a more proactive cybersecurity strategy. The company's Chief Information Security Officer, Amanda Rivera, gathered her team of security analysts and introduced them to the concept of threat hunting. Unlike their traditional, reactive cybersecurity measures, threat hunting would allow them to actively search for threats that had evaded their automated defenses. Imagine our security system as a medieval castle, Amanda began. We have walls, moats, and archers in place. These are our firewalls, intrusion detection systems, and antivirus software. However, some intruders are clever enough to find hidden paths to get inside. Threat hunting is our way of sending scouts to find these intruders before they reach our treasure. She paused, looking around the room. What do you think are the limitations of relying solely on our current defensive systems? As the team pondered this, analyst Mark Chen pointed out that signature-based defenses are often inadequate against new or altered threats. Amanda agreed, noting that attackers continuously evolve their techniques. This led to another question. How can we detect these sophisticated threats that do not match known signatures? Amanda divided the threat hunting process into 3 stages: hypothesis generation, investigation, and response. She explained that hypothesis generation involves making educated guesses about potential threats based on available data. For example, they might hypothesize that a sophisticated attacker is using a type of malware that current antivirus software cannot detect. But what data sources should we consider when forming these hypotheses? She asked, encouraging the team to think broadly about potential intelligence sources. Mark suggested examining logs, network traffic, and endpoint activity. Another analyst, Lisa Patel, mentioned the importance of external threat intelligence reports. Amanda emphasized that combining internal and external data could provide a more comprehensive view. She then moved on to the investigation stage, where these hypotheses would be tested through data analysis. How do we confirm or refute our hypotheses? She asked. Lisa explained that they would need to look for signs of malicious activity within the collected data. This could include unusual network traffic, unexpected file changes, or atypical user behavior. If a hypothesis was confirmed, the response phase would involve actions like isolating affected systems, removing malware, and updating security measures. What challenges might we face in this phase? Amanda queried. The team discussed the potential for high volumes of data, making it difficult to identify significant threats quickly. Amanda introduced AI as a solution to this problem. AI can automate much of the data analysis, identifying patterns that human analysts might miss, she said. But can AI replace human judgment in threat hunting? Mark argued that while AI could enhance their capabilities, human expertise would still be necessary to interpret complex scenarios and develop new hypotheses. Amanda agreed, adding that AI and human analysts must work hand in hand. Machine learning algorithms can learn from historical data to detect anomalous behavior indicative of threats. How might we use these algorithms in our daily operations? Lisa suggested using supervised learning to train models on labeled datasets of known threats, enabling them to recognize similar patterns in new data. Amanda added that unsupervised learning could identify unknown threats by clustering data and flagging outliers. Our networks generate vast amounts of data daily, she said. How can AI help manage and analyze this data effectively? Mark highlighted AI's ability to continuously monitor network activity using sophisticated algorithms to detect anomalies in real time. This would improve the speed and accuracy of threat detection, reducing the workload on human analysts. AI can also enhance threat hunting through techniques like natural language processing and deep learning, Amanda noted. How might we leverage these advanced techniques? Lisa explained that NLP could analyze unstructured data from emails, social media, and dark web forums to gather intelligence on emerging threats. Deep learning could model complex patterns in data, improving the detection of sophisticated attacks. Amanda acknowledged these suggestions, but also pointed out the potential challenges, such as false positives and the need for high-quality data. False positives can lead to alert fatigue, Amanda warned. How can we mitigate this issue? Mark proposed that AI systems should be carefully tuned and continuously updated to maintain accuracy. Lisa emphasized the importance of using high-quality data for training AI models to avoid biases that could render them ineffective. Despite these challenges, Amanda remained optimistic about the benefits of AI-enhanced threat hunting. She cited a Ponemon Institute study showing a 27% improvement in threat detection and response capabilities among organizations using AI. Let's consider a practical example, she suggested. How can AI help us detect insider threats, which traditional security measures often miss? Mark explained that AI could analyze user behavior to identify deviations from established patterns. If an employee who normally accesses specific files during business hours suddenly downloads large amounts of sensitive data late at night, AI could flag this as suspicious for further investigation. Amanda noted that this proactive approach would help detect and mitigate insider threats before significant damage occurred. Concluding the session, Amanda encouraged the team to integrate AI into their threat hunting processes fully. Our goal is to stay ahead of attackers who continuously evolve their tactics, she said. By combining AI's capabilities with our expertise, we can protect our systems and data more effectively. Analyzing their discussion, several key points emerged. First, traditional security measures alone are insufficient against sophisticated threats, necessitating a proactive approach like threat hunting. Second, AI can significantly enhance threat hunting by automating data analysis and identifying patterns that human analysts might miss. However, AI cannot replace human judgment. It must complement it. Third, the integration of AI introduces challenges such as false positives and the need for high-quality data, which must be addressed through careful tuning and continuous updates. Questions like the limitations of current defenses and how to detect sophisticated threats encourage the team to think critically about their existing security measures. Discussing data sources for hypothesis generation and methods for confirming hypotheses help them understand the comprehensive nature of threat hunting. Considering the challenges in the response phase and the role of AI in managing vast data volumes highlighted the practical application of AI in their operations. Finally, exploring advanced techniques like NLP and deep learning, and discussing solutions to potential issues like false positives, underscored the dynamic interplay between technology and human expertise in effective threat hunting. Through this case study, TechSecure Inc.'s team grasped the importance of transitioning from a reactive to a proactive cybersecurity posture. They realized that while AI could greatly enhance their threat hunting capabilities, the ultimate success of their efforts would depend on a seamless integration of AI technology with their analytical skills and strategic insights.